Hello students, I am Brook Alam. Today we are going to discuss about the new chapter, polymers. This is the introduction part. Polymers are macro or large molecules made from smaller repeating units called monomers. Therefore, this is a polymers are what? It is a large or macromolecules made from smaller repeating units. That smaller repeating units called monomers. Therefore, monomers are the building blocks of what? The building blocks of polymers. A number of monomer, it produces a large substance. That large or macro substance is known as a polymer. A polymer made from identical monomer or different types of monomer units. Different types of monomer unit or the same types of monomer units, it produces what? It produces a polymer. Therefore, a polymer made from identical monomer or different types of monomers. The first one is homopolymers. Homopolymers are made from only one type of monomer. The monomer unit is identical. The monomer unit identical, for example, let's take the monomer is A. A number of A produces a polymer. That type of polymer is known as homopolymer. Homopolymer means made from the same types of monomer units is known as it is a homopolymer. Example, polyethylene is synthesized by polymerizing of one type of monomer. For example, CH2 double bond CH2. You know CH2 double bond CH2 is known as ethene. The UPAC name is known as ethene, or the common name is known as ethylene. By using this of a suitable catalyst, it produces this one. By the way, CH2 double bond CH2, this is a monomer. How many monomer units? N monomer units. N is large number. N monomer unit produces a polymer. This is known as polyethylene. Ethylene, polyethylene. This is what? This is homopolymer. Why homopolymer? Because this polymer is formed by the same monomer units. This is the same monomer unit is known as ethene or what? Ethylene. There is no other monomer. The only monomer is ethene. A number of ethene produces, finally it gets a large molecule. This is homopolymer. The other point is copolymer. Copolymers are prepared by polymerizing more than one kind of monomer units. That means A with B, A with B, AB, AB, and so on. Different types of monomer unit produces a polymer is known as copolymer. Therefore, copolymers are prepared by polymerizing more than one kind of monomer. For example, this is CH2 double bond CH2, ethene. CH2 double bond CH, CH3. This is propylene. This one is ethene. This is known as propene. Propene or known as propylene. Propene is one monomer. Ethene is one monomer. Propene is another monomer. These two are the same? No. These two are different monomers. Different monomer n times of ethene with m times of propene by using of a catalyst produces a large molecule. This large molecule is known as polymer. What types of polymer? Copolymer. This is one large molecule. This is known as polymer. This polymer formed by the same monomer units or by different types of monomer units. Different types of monomer units. Therefore, these types of polymer is known as copolymer. Therefore, copolymer formed by different types of monomer units. Homopolymer formed by the same monomer units. Again, these copolymers, based on the way of the arrangement, classify into two types, random and regular copolymer. Copolymers are classified as random or regular based on the way the monomers are arranged along the polymer chain. For example, look this one, A, B, B, A, B, A. This is not regular. This is in irregular way. This is known as random copolymer because the monomer units are not a sequential order. A, B, B, A, B, A. The next step is not predicted. Therefore, this types of polymer is random copolymer. Random means the orders are not in sequential. The other one is regular copolymer. Regular means in a sequential order. For example, A, B, A, B, A, B, A, B, A. What is the next? B, A, and so on. This types of polymer is known as, it is a copolymer, but what type of copolymer? Regular copolymer. Therefore, based on the way of the arrangement, copolymer classify into two types, random and regular. In this case, by the way, A and B are represent what? Monomer units. Polymers on the base of their source. Polymer based on their source classified into two types, synthetic and natural. Based on what? Based on the source. The first one is natural polymers. Natural polymers are found in nature. This is not man-made. This is not artificial. Therefore, natural polymers are found in nature. For example, carbohydrates, proteins, nucleic acids, natural rubber, cellulose, DNA is a good examples for natural. All these polymers are exist in naturally. Therefore, these types of polymers are a natural polymer. The other one, synthetic polymers. Synthetic polymers are, it is man-made polymers. Most of synthetic polymers are organic compounds. You know what I mean by organic compound means? For example, nylon. Nylon is an example of synthetic polymers. Polyester or Dacron, Teflon, bakelite, polyethylene, polypropylene, PVC or polyvinyl chloride is an example of synthetic polymers. Therefore, polymer based on their source classify into two types. One is natural polymer, the other one is artificial or synthetic polymers. Polymerization. Polymerization is the process of combining monomer units to form large molecule is called polymers. Therefore, what is polymerization? Polymerization is a process that gives a large polymers. Therefore, a process of combining monomer units to form a large molecule called known as polymer. That process is known as polymerization. Polymerization can be effected through either addition polymerization or condensation polymerization. Therefore, there are two types of polymerization. One is addition polymerization. The other one is condensation polymerization. Therefore, polymerization is a process of combining monomer unit to produce a polymer is known as polymerization. The first one is addition reaction. Addition reaction is the characteristics of unsaturated hydrocarbons. You know, students, in the lower grade, in grade 9, grade 10, again grade 7, and grade 8, discuss what mean by unsaturated means. Unsaturated means it contains carbon-carbon double bond or carbon-carbon triple bond is known as unsaturated hydrocarbons. Therefore, this is the characteristics of unsaturated hydrocarbons, such as alkenes. You know alkenes. You know the functional groups of alkenes. Alkenes are, it contains carbon-carbon double bonds. And alkynes, this one is carbon-carbon triple bonds. This one is carbon-carbon double bonds. Carbon-carbon double bond and carbon-carbon triple bond is, it is a multiple bond. This multiple bond is under unsaturated hydrocarbons. In addition, reactions, pi bonds are converted into sigma bonds. What does that mean? Look at this one, for example. This is carbon-carbon double bond. By the way, double bond means one is pi, the other one is sigma. In strings, pi bond and sigma bond is not the same. In strings, sigma bond greater than pi bond. One double bond means one pi and one sigma. Therefore, in addition reaction, this double bond converted into carbon-carbon single bond, which bond is break? Pi bonds. Therefore, in addition reaction, pi bonds are converted into sigma bonds. In triple bond also, 2 pi bonds are converted into sigma. Therefore, in addition reaction, double bond and the triple bond is very necessary. The other point is condensation reaction. What is the characteristics of addition reaction? Double bond or triple bonds. Carbon-carbon double bond or carbon-carbon triple bond. This is condensation reaction. Condensation reaction occurs between compounds containing acid and alcohol functional groups or acid and amine functional groups. When condensation reactions takes place, the monomer unit must be contain 2 or more functional groups. Functional group is very important in the case of condensation reaction. What types of functional groups? Like acid and alcohol, because acids, carboxylic acid, for example, COOH, the functional groups of carboxylic acid, OH, the functional groups of alcohol. Therefore, in condensation reaction, acid and alcohol or acid and amine group is very important. In condensation reaction, small molecules such as water can be removed. Therefore, in the case of condensation reaction, some small molecules are removed. Most of the case, removed one is water. Therefore, what is a very important point for condensation reaction? Functional groups. How many functional groups? 2 or more functional groups. Most of monomer contains what? Acid and alcohol. One is acid, the other one is alcohol. Or one is acid, the other one is amine. Acid with amine, acid with alcohol, combined together, finally produces a polymer. Small molecules are removed. These types of process, these types of reaction is condensation reactions. For molecules to undergo addition polymerization, they should have double or triple bonds in their structure. Addition polymerizations takes place, the monomer unit must be contain double bonds or triple bonds, because pi bonds are very necessary. Carbon-carbon double bond, carbon-carbon triple bond. Molecules that can undergo condensation polymerization, it should have 2 or more, what? 2 or more functional groups in each molecule. One molecule contains 2 or more functional groups. Therefore, molecules that undergo condensation polymerization, it should have contains what? 2 or more functional groups like acid and alcohol, acid and amine, and so on. Addition polymerization. It requires a large number of monomer molecules which can be polymerized by what reactions? Addition reactions. It requires a large number of monomer molecules which can be polymerized by addition reactions. For example, look this one. CH2 double bond CH2. This is known as what? Ethene or ethylene. Ethene, IUPAC name. Ethylene, common name. How many ethene? How many ethylene? N-ethene or N-ethylene. By using this of a catalyst produces polymer. Look this one. CH2 double bond CH2. Already CH2 means CH double bond CH. How many ethylene? N-ethylene. N-ethylene. But which bonds are break? Pi bond or sigma bond? Pi bonds are break. This CH2 double bond converted into CH2 single bonds. Therefore, this is monomer ethylene. Polymer is polyethylene. Therefore, polyethylene is an example of addition polymerization. Because the monomer unit, it contains carbon-carbon double bonds, pi bond converted into sigma bonds. The other one is styrene. By the way, this is styrene. Styrene, N times of styrene, this is carbon with carbon double bond. The only difference, this double bond converted into single bonds. How many times it increases? N times it increases. Therefore, ethylene produces polyethylene. Styrene produces polystyrene. Therefore, both polyethylene, polystyrene, and polyethylene is an example of addition polymerization. If a polymer is given, you can identify the monomer units as the repeated one. The repeated one is the monomer unit. Look this one. The addition polymer of polyvinyl chloride. Poly, P, vinyl, V, chloride, C. Look, polyvinyl chloride. The first three letter is what? PVC. PVC means polyvinyl chloride. This is the structures of the polymers for PVC. A, draw the structure of the monomer from which PVC is made. This is already polymer. What is a monomer? B, how many monomer units in a PVC polymer that has a molecular mass of 1.33 times 10 raised to 5 gram per mole? How many monomer units are combined together to give the molecular mass of the polymer is 1.33 times 10 raised to 5 gram per mole? Which one is repeated? Look, CHH, CHCl, CHH, CHCl. Therefore, this one is repeated. Look, this is one. This is another point. Again, this is another. This one is what? This is a repeated one. Repeated. Carbon, HH, HCl. Carbon, HH, HCl. Carbon, HH, HCl. Therefore, repeated. And so on. The next step is again carbon, H, H, carbon, H, Cl, and so on. This is another repeated. Therefore, the repeated one is already known. Look, this one. This is the repeated one. And so on. What is the repeated point? Carbon, H, carbon, H, carbon, H, carbon, Cl. This is what? The repeated one. Therefore, the repeated one, this one. But the monomer must be contains what? In addition reaction. Nice. The monomer must be contains double bonds. Therefore, by removing off this one and this one forms this structure. Carbon, double bond, carbon, H, 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 Cl. What is this? This is the monomer of what? PVC. This is known as what? Vinyl chloride. Vinyl chloride. The monomer is CHH, CHCl. This is the monomer of what? The monomer of PVC. Therefore, the monomer must be the repeated one, but convert in the forms of double bonds. B, find how many monomer units. The question is, how many monomer units are required to produce the molecular mass of the polymer is 1.33 times 10 to the power of 5 gram per mole. Now, to determine the number of monomer unit is what? Number of monomer unit is equals to molecular mass of the polymer divided by the molecular mass of the monomer. Already you know the monomer. This is the monomer. Carbon, carbon, H, H, Cl, Cl. Already this is determined. This is a monomer. Molecular mass of the polymer already given. How much is given? 1.33 times 10 to the power of 5 gram per mole. Already this is given. How many carbon? 2 carbon. 12 times 2, 24. How many hydrogen? 1, 2, 3. 3 hydrogen. 1 times 3, 3. Vinyl chloride, how many chlorine? Already 1 chlorine. 1 chlorine. Atomic mass is how much? 35.5. The sum of 24, 3, and 35.5, it gives 62 0.5. Therefore, 62.5 is the molecular mass of the monomer. By dividing molecular mass of polymer to molecular mass of monomer, it gives the number of monomer units. How much? 2,128 monomer units are required to produce a polymer. Therefore, this is what? 2,128 what? 2,128 is the number of monomer units that give the molecular mass is this one. Condensation polymerization. In condensation polymerization involves the combinations of monomer molecules with elimination of simple molecules like water. In order to produce a condensation polymer, the monomer involved must have 2 or more functional groups. You know, already discussed. In condensation polymerization, the monomer must be contain 2 or more functional groups. Example, when an alcohol with 2 OH group, this is alcohol, ROH. ROH is the functional group for alcohol, ROH, react with a dicarboxylic acid. You know carboxylic acid functional group, COOH. Di means 2 types of COH. Therefore, R prime, this one is R prime, COH, R prime, COH. What is the monomer in this case? Alcoholate, acid. What types of alcohol? Dialcohol. What types of acid? Diacid. Dialcohol with diacid. In this case, the ester is formed. With dialcohol and diacid combined together, the ester is formed. Still have an reactive group in both ends of the molecule. Look, this structure. ROH. This is alcohol. This is carboxylic acid. This is dialcohol, by the way. Dihydroxy, or 2 OH groups are present. OH. This is acid, COOH. How many COH? Look, COOH. Another COH here. Dicarboxylic acid. From alcohol, removing of H. Because this is HOROH. Acid part is HOC double bond O R prime COOH. From alcohol, removing of H. From carboxylic acid, removing of OH. Finally, H with OH produces what? Produces water. Therefore, waters are removed. In addition reaction, the removed substances are not present. But in the case of condensation polymerization, small molecules are removed, such as water. Therefore, waters are removed, finally produces this ester. But this ester, again, a reactive end. What is a reactive end? This H removed by other carboxylic acid. Again, this OH removed by other alcohol. Therefore, this ester is again, it contains what? Active end. Why active end? Because one part of the alcohol, H, removed. Again, the other part of OH, again, removed. This is continuously. Therefore, these types of process is condensation polymerization. Exercise. Draw the structure of the monomers that would be used to make the following polymer. Already this is a polymer. What is the monomer unit of this polymer? First, look. CO, benzyl ring, CO. Therefore, this is 1 point. CH2, by the way, CH2 means CH2, 2 times. O, another point. Therefore, the monomer is this one. C, double bond, O. Already this is the ring. This one is this one. For carboxylic acid, removed what? OH. Look, OH, OH. In both sides, OH from this position, OH from here. Therefore, this is what? One monomer. The other monomer is what? CH2 2 times OO. From alcohol, always removed what? H. Look, this is H. Again, from here, H. Therefore, this is a monomer. In this case, adding of OH. For carboxylic acid, add OH for CO position. How many times? 2 times. OH, OH. In the case of alcohol, adding of H, attached with oxygen. Already oxygen is here, attached to H. Oxygen is here, attached to H. Therefore, this is the monomers of these polymers. The other one is, this is already a polymer is given. From this polymer, what is a monomer unit? Look, first, which one is a repeated one? Carbon, carbon, HHCl. Carbon, carbon, HHCl. Already, Cl, 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 HHN. Therefore, this is one. The repeated one is this point. Therefore, the repeated one is carbon, carbon, H. Already, this is H. This one is chlorine. This one is chlorine. To form a monomer, use simply double bond. Therefore, this is a monomer. The monomers are by using soft double bond. This polymer is formed by addition polymerization. But the previous one, this one, is formed by, this one is formed by condensation, polymerization. But in the case of this one, this is already monomer unit, monomer unit, monomer unit. This is addition reaction. The monomer must be contains double bonds. 2 types of polymer based on their source. One is natural, the other one is synthetic. Therefore, this is under synthetic polymer for addition polymers. One is polyethylene. Look, students, this one. Already this is polymer. This is a polymer. This one is monomer. N times of already monomer. The monomer is known as ethylene or ethene. Converted into polymer, which one is break? Double bond means what? Pi and sigma. Pi bonds are converted into sigma bonds. Therefore, pi bond break, the bonds are from this position and this position. This one is can be formed. Therefore, this is what? Polyethylene. Polyethylene is formed by what? Ethylene, or known as what? Ethene. How many ethene? N ethene. You know N determined by molecular mass of polymer divided by molecular mass of monomers. Therefore, this is formed by addition polymer. Therefore, polyethylene is, it is a synthetic polymer formed by addition reaction. Why? Because the monomer unit, it contains double bonds, carbon-carbon double bonds. The properties of polyethylene is what? One is no taste. Polyethylene is no taste or odor. It is a lightweight, non-toxic material, relatively very cheap. Some of the primary uses of polyethylene is squeeze bottle, garment bag, trash bag. Look, these different types of polyethylene material. You know this material, very common. This is polyethylene trash bags. This one is squeeze bottles or sometimes wash bottle. This is another material, polyethylene tube. Therefore, this is some materials formed by polyethylene. The second one is polypropylene. In the case of polypropylene, this is a monomer. The only difference, H substituted by CH3 in the case of ethylene. Therefore, this is propylene. Already N times of monomer unit finally produces a polymer. What is the change? Double bond converted into single bond. This is propylene or propene. The polymer is polypropylene. Therefore, polypropylene is a polymer. What is the monomer unit? The monomer unit is propene or propylene. This reaction takes place by addition reaction because double bond is converted into single bonds. This one is stronger than polyethylene. Polyethylene is very light. Polyethylene is very cheap. Therefore, this one is stronger than polyethylene. This one is used for making food containers. You know different types of food containers. You know this material. This is polypropylene rope. This one is polypropylene carbate. You know again this material, polypropylene bottles. Therefore, this is some of the materials formed by polypropylene. The third one is polyvinyl chloride or PVC. The monomer of PVC is vinyl chloride. Look, carbon, double bond, carbon, H, Cl, N times. By using this of a suitable catalyst, produces carbon, single bond, carbon. One of the pi bonds are converted into sigma. The other one is Cl. This is continue. This one is continue. How many times? N times. What about this one? Vinyl chloride. What about this one? PVC, polyvinyl chloride. Polyvinyl chloride is a polymer. Vinyl chloride is a monomer. By the way, PVC is copolymer or homopolymer? Nice. PVC is homopolymer because the monomer unit is identical, only vinyl chloride. Therefore, this is a monomer. The monomer is contains one chlorine attached with one carbon atom. It is commonly used for making pipes. PVC is very important, especially for making pipes. You know different types of pipe. This is a pipe, PVC pipes. Laser-like material, shoes, raincoats, aprons, floor tile is formed by using of PVC. Therefore, this is PVC pipe, PVC floor tile, PVC raincoats, PVC. This is all about today's lesson. Until next time, goodbye.